What is a polygon? A polygon is a two-dimensional closed shape made of straight lines. Now what this simply means is that, let's say for example I have a line here and then another straight line here. We cannot call this a polygon because polygons are made of a closed shape. So it has to be closed for me to be able to call it a polygon. Now, let's say we remove this line here and then we place it with like a curve. This can no longer be called a polygon because polygons are made of straight lines. So for it to be a polygon, it has to be made of straight lines and it has to be closed. What are polygons made up of? Every polygon has a side, has sides, vertices, and interior angles. Now the sides are the edges, while the vertices are the points where the side meets. This point where the side meets, these are the vertices. And then the interior angles are the angles that are inside the shape. Now inside this shape, there's an angle here, there's another angle here. These angles are known as the interior angles. Now let's move into types of polygon. For the types of polygon, we are going to characterize them based on their number of sides. A polygon with 3 sides is called a triangle. A polygon with 4 sides is called a quadrilateral. A polygon that has 5 sides is called a pentagon. And a polygon that has 6 sides is called a hexagon. A polygon that has 7 sides is called a heptagon. A polygon with 8 sides is called an octagon. A polygon with 9 sides is called a nonagon. And the list keeps going like that depending on the number of sides the polygon has. Now that we know what types of polygons we have, let's classify them. The first class we're going to be looking at is a regular polygon. Now, in regular polygons, all the sides and the interior angles are equal. Perfect examples of regular polygon are squares and equilateral triangle. Now let's assume this square, this side of the square is equal to this side of the square and equal to this side and also equal to this side. This is a regular polygon. Now this angle too also has to be equal to this angle and equal to every other angle in the polygon. Now for this equilateral triangle, this side must be equal to this side, must be equal to this side. So the 3 sides must be equal and all the angles too must be equal. This is a regular polygon where all the sides and the angles are equal. The next is irregular polygons. In irregular polygons, all the sides and the angles are not equal. Remember that for it to be a regular polygon, all the sides and the angles must be equal. Now, if all the sides and the angles are not equal, it becomes an irregular polygon. Number 3 is convex polygons. Now, in convex polygons, all the interior angles are less than 180 degrees. Now let's say we have this triangle and this side is, say, 120 degrees, and this side is, let's say, 40 degrees, and this side is 20 degrees. Since each of the interior angles, all of them are less than 180 degrees, it is a convex polygon. Number 4 is a concave polygon. Now when we talk about concave polygons, at least one of the interior angles must be greater than 180 degrees. Let's say, for example, I have this polygon here with, this is an interior angle, let's say this greater than 180 degrees, and then something like this. This is a polygon. Now, since one of the angle is greater than 180 degrees, let's say this is like 195 degrees. Since one of the angles is greater than 180 degrees, it gives it a caved in appearance. That is why they are called concave polygons. Let's move into the more interesting part. Now, for every polygon, the sum of the exterior angles is always equal to 360 degrees. Whether it is a triangle, a quadrilateral, a pentagon, no matter the number of sides of the polygon, the sum of the exterior angle is always equal to 360 degrees. Now for the interior angles, the sum of the interior angles of a polygon depends on the number of sides of the polygon. So we say the sum of the interior angles is equal to n minus 2 times 180 degrees, where n is the number of sides of the polygon. Now, let's say, for example, we are asked to determine the sum of the interior angles of a pentagon. We would say the sum of interior angles of pentagon is equal to, since the number of sides of a pentagon is 5, we would replace n with 5. 5 minus 2 times 180 degrees. That would give us 3 times 180 degrees, which is equal to 540 degrees. Let's try out some other examples. This question says, find the sum of the interior angles of a hexagon. Now the first thing we're going to think of is, how many sides does a hexagon have? Recall, a hexagon has 6 sides. That means our n is equal to 6. Now, to determine the sum of the interior angles of the hexagon, we would say the sum of the interior angles, the sum is equal to n minus 2 times 180 degrees. Since our n is 6, we'd say 6 minus 2 times 180 degrees gives us 4 times 180 degrees, which is equal to 720 degrees. So the sum of the interior angles of a hexagon is equal to 720 degrees. Let's try another example again. Now this question says, find the sum of the interior angles of a 10-sided polygon. A 10-sided polygon means that our n is equal to 10. Now, the sum of the interior angles of a 10-sided polygon would be 10 minus 2 times 180 degrees, which is equal to 8 times 180 degrees, which is equal to 1440 degrees. Now, what if you had a question like this? The sum of interior angles of a polygon is 900 degrees. How many sides does it have? Notice that in this question, we're not given the number of sides of the polygon. So now the first thing we'll do is to write out our formula, which is the sum of angles of a polygon is equal to n minus 2 times 180 degrees. Now, since we're already told in the question that the sum of the interior angles of the polygon is 900 degrees, let's replace sum with 900 degrees. Then we would have 900 degrees is equal to n minus 2 times 180 degrees. When we divide both sides by 180 degrees, we would have 900 divided by 180, which is 5, is equal to n minus 2. Now, when we collect like terms, we would have n is equal to 5 plus 2, n is equal to 7. Hence, the number of sides of this polygon is equal to 7. And a 7-sided polygon is a heptagon. So this polygon is a heptagon. Would you be trying out more examples?